Thus you have to keep track of multiple Chainlink requests using a mapping. So I'm going to be using this workshop honeycomb request repo as the base project. So I cloned it, created the wallet.json file, installed the dependencies, and if you remember, contract makes a request to generate a random number, and then in the callback function, this result is written to a variable called result, and then a flag is set to true to show that the result has been received. Now the problem with this approach is if you make a new request, then the old result is going to get overwritten, and you may need the previous answer because, for example, two users may be using this contract simultaneously, and when one makes a request, the other's result shouldn't be overwritten. And we're going to be using a mapping type to prevent that. So instead of having this basic types, we will have this mapping, and requests are identified by the request ID, which is returned by this function as a byte 32 type. So that's why in the mapping we map byte 32 to bool, and do the same for the integer. So now when I make the request, I will get a request ID, and if I want to get the result of that request, I will index this mapping with my request ID, which is going to give me the result. And let's change the name as mapping, although not a very good practice. Result receipt mapping and result mapping. And I'll change this to 1 to 100, so the random number is going to be between 1 and 100. I will delete this one because I cannot reset the mapping like this. And then the fulfill function. Now this is a mapping. It should be indexed by the request ID. And finally, we need a getter function. Oh, by the way, the name also should be mapping because we changed the declaration. And then we need a getting function, get result, and the input argument is the request ID. So now when we feed the request ID to this function, it returns us the result by indexing the mapping by the request ID. And let's do the same for the flag. So now, if I made the request, got the request ID, I can call this function to get my result. And we're going to be changing this test script. So I deleted the reset result function, so I will delete this. And I don't need to print the initial values. So what I'm going to do is, I'm going to make a Chainlink request, get the request ID for that, wait for it to get fulfilled. I will make another Chainlink request, get its request ID, wait for it to be fulfilled, then get the answers from the contract and print them. By the way, we should be deploying this, the contract. So the migration script is not going to change because we didn't change the constructor. So we deleted the reset results and the printing the initial result part. And here we make the request, we wait for it, and then we print it. So before printing, we will make another request here. And the thing is, we want to keep the request ID, so we need to name it differently between the two requests. So I will say request ID 1 and 2. And here, these are now mappings, so I should be using my get functions, get results, and get result received. And these are going to be needing the request ID as the input argument. So we get the first result here and the second result here. And if we see two different results, it means that our second request didn't overwrite the first one, which is what we expect. So we can also map these requests to users, for example, in the contract. When we get it here, we can map a request ID to an Ethereum address, for example, and then only return the result to the Ethereum address that made the request. And overall, this mapping pattern is, you would need to use it quite frequently when using Chainlink, because the oracle is not specific to your smart contract. You're using it with other people together, so somehow you should be able to identify processes. So we deployed the contract and let's run the test script. So this is the job ID. Let's check Explorer. So this is my first request ID. Of course, it would make more sense if I did the requests first, then waited for the events to be emitted. Now, we're roughly waiting double the amount that we should be if we did it that way. I was talking about it in Discord. So what's happening right now is basically the node is waiting for 3 confirmations before it starts working, because calling this external adapter is, it probably costs the node to call this. For example, with Honeycomb Marketplace, the node operator will pay an API call price, and then this also costs the node gas, so the node wants to be sure that it has received the request, so which is why it is waiting for 3 confirmations here. So the request is fulfilled. We didn't print it yet. We are making a second request. And it is also fulfilled. Surprisingly close. So after we got the responses, we called the getter functions to get the first results. So we have received the result true, and the result is 33, and we print it. And then we use the getter function to get the second result using the second request ID, and then we print those. So obviously you can do this. For example, this request can be to one ID, one API, and this request can be to another API. And then you can keep track of requests done to different APIs, for example. As long as they're the same type, for example, if they're returning a signed integer, then you can use the same mapping. And if these APIs returned different types, then you would need, for example, you make one call to an API that returns a signed integer, and then you make another call to another API that returns a byte 32 type. Then you would need another mapping like this. So that's it.